Hi, Professor Schreiner. It's a pleasure to have you here at the Department of Chemical Sciences of the University of Padova. He's the professor of organic chemistry of the University of Gießen, a university with which we have a lot of contacts, a lot of exchange with students, ideas and projects. Again, welcome and thank you for being here.
Thank you for inviting me. It's a pleasure being here. Yeah, it's a beautiful place, great department, so thank you.
First question, really general. What is the chemistry of Pnictogen and why is so important?
Pnictogen chemistry, so mostly nitrogen, phosphorus, arsenic, and so forth. The first two are definitely elements of life, like carbon, oxygen, halogens, hydrogen. It's also nitrogen, phosphorus. You know, if you think where nitrogen is in the alkaloids everywhere, phosphorus is the basis for DNA and RNA. So these are really the elements that shape life.
And you and your group have recently made a new discovery, really important discovery, a new nitrogen allotrope. What do you think that this will impact the next research in chemistry in the next decades?
Well, my hope is that we have now opened the door to nitrogen allotrope chemistry. You know, there was nitrogen N2, and there were hints at some allotropes that they might exist as molecules. I mean, there are allotropes under high pressures and high temperatures in a solid state, but as molecules, there really weren't any that you could look at. And now N6 is the first one, and I think it will not be the only one. I think people now realize, wow, you can make these molecules. What other molecules, what other allotropes nitrogen can I make? And that will open, you know, a big door. Now we don't know whether there's a beautiful garden behind that door or it's a dark cellar. So we don't know that, but at least we know it is worth trying, and the likelihood of finding something exciting is pretty high.
And just a general comment. What do you think that is the most important thing for students like us, as PhD students, young researchers, for the development of a chemical curiosity and also in the direction of exploring chemical spaces?
Well, to live out curiosity means you need to know quite a bit, to understand what is known, what is unknown. The curiosity can only be concerned with what we don't know. You can only be curious about something you don't know. So you need to study hard, learn your stuff, and know, your basics, and then be courageous and really say, I want to, check this out because I think there may be something new that nobody knows. And then the answer to thinking about this is simple: just do it. Don't think too hard about it. You have an idea, talk to your supervisor, say, this may sound crazy, let me try it. And a good supervisor will tell you, go for it. Of course, you're not supposed to do many things at a time that are, of unknown result. But once in a while, you need to try something that looks a little bit crazy and just do it, not to think too much about it.
Thank you very much.
My pleasure. Grazie mille.